So yeah, up next we have Shady. So a brief intro to Shady. Shady El Damaty holds a PhD in neuroscience from Georgetown University, where he worked at the intersection between computational science, cognitive neuroscience, and biomedical engineering in the interest of the advancements of human society. Shady founded OpScientia to achieve this vision, building on 10 years of method development and digital infrastructure for big data and neuroscience research. On a personal note, Shady is also one of the first people I met when I was moving my first step into DeSci. So I'm really excited to have you, Shady, today. Thank you for joining us at SciCon.
Thank you. It's so good to see friends in this space, and it's amazing to really track the development of something that was just perhaps whispers across the internet. And here we are all together online and talking about real implications of how web native communities can change how we do science. So today I have a bit of a more scholarly, perhaps research-based approach. I want to talk a little bit about mechanism design in DeSci and some really kind of high-level topics regarding primitives. And so a little bit of context. Thank you for the intro. I'm glad that I don't have to talk myself up. I really appreciate it. So as a part of OpSci, the work that we've been doing, thinking really carefully about mechanism design, architecture design patterns, what does the DeSci stack look like? And how do all of the different pieces, can we identify the individual primitives or pieces? So can we identify these primitives and how do they all fit together? And what are the consequences of the different decisions we need to make as we deploy these things? So in summary, what I'll talk about today, I want to make sure that, maybe I'll bring out this concept at the beginning and then we'll revisit it again at the end. So I'll cover discovery, how it's traditionally been applied throughout scientific history, with a very specific example of how discovery really is a recursive arc, right? So you can't chart discovery as a linear or even like a traditional standard nonlinear exponential model, but it's probably something much more complicated than that. Then I'll also talk about something called positivism and how positivism, being aware of its consequences and role in the history of the philosophy of science, is something that we should revisit as we're designing these DeSci DAOs for autonomous knowledge curation. And lastly, I'll cover some just basic reflections or ideas on what these DeSci primitives are. And again, this is an open question, and this is something that we're going to have to solve as we're moving forward. And so don't take anything as authoritative in this work. And yeah, so let me just hop right into it. So I kind of alluded to this already, right? This concept that discovery is a recursive arc. And what this means is the path that we chart to discover what is real and what isn't real and how it impacts our lives is driven primarily through falsification, right? So that's at the heart of the scientific method. If you can disprove something, or if you have a model that's set up to disprove things, this is going to drive your explanatory power over time, right? And it's a little bit counterintuitive. It's like, oh no, my model should prove things. My model should explain and make predictions. However, deep within the philosophy of logic, of mathematics, of computer science, you have some fundamental results that maybe we can cover in a little bit more detail that, TLDR states the models that we construct to explain the world, depending on their explanatory power, are always going to end up with paradoxes or contradictions. And if we make them such that they explain everything, especially so. So a really great example of this recursive arc is the cultural inertia, and I guess this cultural inertia that science had to, and you could say decentralized science had to overcome in the transition from the practice of science as alchemy to chemistry. And this was a multi-century progressive march forward. And you could argue that this was an example of really low-tech decentralized science, right? So you had all of these individuals all throughout the world doing different types of experiments at the same time, corresponding about them, with incredible time lags between when the results are known and when they're not known. So for a little bit more context, when we were some of the first models to emerge regarding kind of the composition of the natural world were emerged from alchemical studies. So this idea that there are basic elements in the world, and this goes all the way back to Greek philosophy, right? Of like different types of forms, or like Platonic, specifically like Platonic forms. So a great, right around the late 1600s, this gentleman, J.J. Becher, he wrote a really influential document that took these alchemical forms to try to explain the question, how do these things burn? Took these alchemical forms and modified them to explain this question of how do things burn. So, he's famous for saying that there's 3 types of earth, as well as air, fire, and water. And these are pure forms, like air is air. So this was really, really significant. Later on, Stahl, a different early chemist or alchemist, if you want to call him that, he identified that this 3rd form of earth called terra pingus, which is this like waxy, oily sort of substance that forms during oxidation as we know it now today. He identified it as phlogiston. And phlogiston was supposed to be this chemical that is consumed or released or facilitates fire, facilitates burning. And it's really interesting because in the beginning, this kind of emerged out of experiments. So, if you, you could like extinguish a flame by capping it, by making sure that all the phlogiston is expended, right, within that system. And so, this theory started to pick up a lot of steam. And by the early 1700s, this individual named Potts started writing and condensing and synthesizing a lot of these basic observations and theories for a mass audience consumption, right? So he wrote all the TLDRs and he said, hey, everyone, fire is phlogiston. And this became the dominant form of thought for like 100 years, just about. And it wasn't overturned until this really famous chemist, you guys might know him, Priestley, discovered that actually oxygen is something that exists. And he incorrectly assumed that oxygen is just dephlogisticated air. So the fact that experimental evidence couldn't continue to support the existence of a specific chemical called phlogiston or a specific substance called phlogiston, right? Something that emits and it's like permeates all of the air and the universe. It's just something that's part of the fabric of the universe. Was kind of this convergence that people came to the point where it's like the experimental evidence was very difficult to observe those things. And so it resorted to becoming a process. And Priestley incorrectly surmised that, hey, oxygen is just what happens when you dephlogisticate air. It wasn't until Lavoisier actually discovered oxygen and founded the modern field of chemistry before he got his head chopped off in the French Revolution. And really gave us this conceptual framework that was completely different and revolutionary from what had come before, which is this concept of chemical reactions and laying the path forward for chemical structures and the emission of energy during chemical reactions. So, these early DeSci primitives that these individuals kind of relied on, right, was the ability to observe, perturb, and synthesize before doing it all over again, right? So you observe a system, you see what you measure what you can measure, you synthesize those measurements, you perturb the system to see how it responds in different conditions, and then you observe again, and you keep repeating the same process. And so this is rooted in a philosophical, I guess, school of thought called positivism, which basically states that anything that's rational is real, and anything that's real is rational, to quote Hegel, right? So if you can observe it, it probably exists. If you can't observe it, it doesn't exist. And this became a pretty dominant doctrine for quite a while, until the emergence of quantum mechanics, right? So Einstein was a really famous opponent of logical positivism in the philosophy of science, because he was very intimately aware that there are things that we can't observe that we know exist, like electrons or quarks or the Higgs boson, right? We can only measure shadows of them. The Higgs boson much later on. So why am I even talking about this? Why is this important? Positivism, I think, is something, and its history and how it was successful and how it failed is really, really important to keep in mind when we think about automating knowledge systems. So specifically in DeSci, I have a definition that I've thrown up there. There's many, many definitions out there, but I think we would probably all agree that at least the sub-definition, a sub-definition would be DeSci could be characterized as this web native movement to bring the practice of science, into a digital space where individuals could deploy scientific applications on decentralized internet protocols, right? So these are public goods. They don't run on any particular trusted party. They're distributed, they're autonomous, they're community owned, and they have some really interesting key properties, right? So that they're on these distributed consensus networks that have deterministic criteria, where knowledge curation is an engineered process, right? It kind of taking this concept of science as software to the limit. And this is underlined by things like linked and verified content, right? So being able to cryptographically generate proofs that a particular object or a particular observation is that observation that came from that source. So reducing noise in the communication of results all the way from observation to dissemination and published papers. Some other key properties are things like algorithmic grant making. So how do you actually chart a problem or hypothesis space and allocate resources to different parts of it so that you maximize your odds of finding the lowest local minima in that entire space? Like, how do you find theories that are the most powerful in their explanations, and how do you allocate resources to accelerate that convergence? And a big part of this is economic engineering, right? Where you perhaps match decentralized service providers, everything from peer review, curation, contract research organizations to run your PCRs with scientists that are interacting in this web native community. So if we kind of take a step back and think about this, early primitive DeSci DeSci process, right, where you are linking observation with synthesis and perturbation as part of this convergence towards an explanatory model. So it's really important to remember that automation is really, once things are automated, they're going to be really efficient at what they do, especially in a deterministic system. A deterministic system is going to do what it's intended to do. And incentive mechanisms, especially in economic systems, will converge to equilibria. And these equilibria can be self-reinforcing, right? And maybe I can give some examples of this in a minute. So keeping in mind that synthesis is always going to be constrained by the resolution of our telescopes, by the statistical power of the observations we're able to make. And economic incentives that are dependent on that synthesis will lead to equilibrium points, right? And one key risk here is that poorly designed systems, or systems that are designed for one purpose and applied for a different purpose, like across scientific fields, have a risk of getting trapped in a local minima, right? Or these self-referential models like phlogiston. Except imagine that phlogiston had an economic system to maintain its presence, or to maintain its significance, right? So like imagine you had journals that would only make publications available that regarded phlogiston, or grant-making institutions that wanted to explore phlogiston. And the way that it was defined is in a very self-referential way. So you could have like a really elaborate, complex model with self-referential claims that all seem true, but in reality don't provide any further explanatory power. If you're interested in kind of thinking more about autonomous protocols and exploring these concepts in more detail, do check out this paper that we wrote with the Active Inference DAO, which synthesizes a top-down and a bottom-up approach of science to think about what does deep and wide protocol system design look like for knowledge engineering. And there's a lot there. It's a very, I think, it's a very young field, and it has a lot of interesting intersections with models and research and artificial general intelligence. And when we go into that paper a little bit. So let me see how I'm doing on time. Okay, I think I'm good. So what do modern DeSci primitives look like? Okay, so these are my suggestions here, kind of collapsing across the different components that we would use to build these DeSci autonomous science protocols. And these are primitives that we need to keep in mind when we're designing for explanatory power and avoiding some of these pitfalls, right? So at its core, we have things at the core of DeSci, we have community, right? It's decentralized because there's people out there that want to connect, that want to do research, that want to work together, and culture is what bridges them together. This also includes, not just individuals, but the existing scientific status quo, right? So labs, institutions, governments, focused research organizations, right? So that whole ecosystem, or that pond that has all of the different types of life forms that are working together to interact and decide what are good research questions and how to evaluate them. So the community, I believe, is pretty much at the heart of this. And funding and grant making is what allows this community to do what they do, right, as opposed to getting a job. And especially thinking about alternative funding mechanisms like fast grants or crowdsourcing, tokenomic sorts of systems or crypto economics. And then also there's a role for traditional government grant making as well as philanthropic proceeds. And of course, as we've been seeing in kind of a recent trend, the role of equity and venture capital in merging these crypto economic systems with commercialization and applied research. So we also have execution. Execution are going to be basically the primitives that allow us to observe and perturb systems. So these would be, for example, decentralized networks of research laboratories, maker spaces, community labs, institutions, and other service markets, like, for example, what LabDAO is doing. Coordination, right? So this is kind of a super category of all the mechanisms that we require to be able to debate and converge to specific models or specific understandings that's shared across the community, right? Like, how do we actually assess problems, and how do we, identify weaknesses and strengths of different explanatory models? And that's, I think, kind of at the heart of what's happening at ResearchHub. So this includes things like, snapshots, sentiment signaling, and different types of forms or mechanisms of forms and polling. DAOs and sub-DAO models are really interesting here as well. Asymmetric kind of comms, so the ability to put a lot of people together, bring a lot of people together on the same page through these web native mechanisms. Like Telegram's a great, maybe terrible example of one. Discord's in that mechanism as well. So it's I think thinking of those things together as providing a set of tools that allow us to build a coordination, tools for coordination to establish community and culture, and be able to do things like execute research that's been funded. The last two components I'm just going to briefly bridge over, and I think they're really important, which is synthesis, which we've been talking about, but thinking specifically in a modern context where we have these reproducible knowledge objects that allow us to do things like meta-analysis, allow us to build discourse graphs that track how a conversation changes over time, so that we can take a step back and ask the question, how does fire really burn? What is oxygen? What is phlogiston? And this is going to be really dependent on looping in the rest of the community, bringing them all up on the same page, communicating scientific results through publishing and sharing. And I think some of the key components for publishing are things like cross-references across different avenues, right? So the existing legacy systems have to be plugged into DeSci. We need to have mechanisms for plugging into Crossref, into Scopus, the DOI system, and building into those feedback mechanisms that allow us to weight the importance of different research results. So when we're thinking of engineering knowledge curation, right? So this ability of making scientific discourse more automated, more programmed around specific outcomes and metrics, my argument is that we should do so around maximizing the propensity of falsification, or the power of falsification. So what I mean by this is that those protocols or mechanisms or tools that allow us to more quickly iterate and converge on the boundary on the boundary limits of the particular space that we're trying to describe, the more likely we're going to be able to build something that's actually useful. And these primitive design principles regarding how we do that, this should be done out in the open. So builders, different types of communities should come together and document some open source design principles for their primitives, whether it's an astronomical community that requires very specialized hardware and software for converting signals from the James Webb telescope into objects that can be manipulated by any scientist around the world, right? And plugged into existing academic discourse in a digitally native, seamless fashion, right? Kind of like thinking about what DeSci Labs is doing with DeSci nodes, as an example. It's also really important to kind of get away from this tyranny of a holistic solution, or the imminence of a holistic solution. There's never going to be one DeSci DAO. There's never going to be one solution or one protocol or one set of parameters that's going to fit all these, all fields of science, right? Because different knowledge problems are going to require different primitive configurations and different embeddings, right? Like in terms of how that research is funded, what its time horizon for impact is, its reliance on specific types of precision or specific types of data. And so we don't want to fall into a trap where we're designing economic mechanisms that uplift certain types of science, for example, like biotech, and perhaps suppresses or ignores other types of systems or other types of scientific fields of inquiry, like social psychology, like behavioral economics, and so on and so forth. So, and keeping in mind all along the way that failure should be considered a virtue. We should be building these systems again to fail. And the faster we do this, and the more quickly we are able to chart quantitatively boundary conditions for these different types of DeSci protocols, the better off that we will be. Just kind of really hammering in that point again. So that's all I have to say for today. These are kind of thoughts that have been coming up in some of the research I've been doing, thinking about basic protocol system design and how do we build autonomous knowledge curation protocols, and thinking about dissemination and what are some good primitives for that. So there's a lot more under the surface here. If you want to get involved in this stuff, join a practicing DeSci DAO. And ask yourself questions. What are the tools that are being implemented here? How is the community executing sense making in a distributed fashion? How are they taking those observations and synthesizing them? What are their tools for perturbation? And I think it's really important to practice kind of intentionality and understand that this is going to be a convergent process with many failures along the way. And yeah, help us design some primitives and deploy the DeSci stack architecture. There's an active conversation going on. Check it out at hack.opsci.io. You can also check out our blog on pulse.opsci.io to kind of get a feeling for how we're thinking about these things. And yeah, no, I don't want to take up any more time. So thank you for letting me wax philosophical on you guys on this Sunday. Appreciate it. If you have any questions, you can post them after this as well on the OpSci forums.
Okay, thank you so much, Shady. That was really interesting. Thank you again for bringing your perspective on autonomous DeSci protocols. So as you said, since we're running a bit behind, I would ask anyone that has a question. I don't see any for the moment in the Q&A, but if you have any question, please reach out to Shady. Again, it's been a really interesting. I think it's a really interesting topic, especially for when DeSci goes into people start to learn more about DeSci and how they could actually implement all of these things. That would definitely be there's going to be a learning curve there, but I think it's really important that we start to bring this more and more into the traditional academic system. So thank you again, Shady, for coming up today to SciCon 2022.
Thank you for the invite.